Edexcel Decision 1, Critical Path Analysis 3, Resource Histograms and Scheduling. Leveling resource histograms. So resource leveling helps to ensure there is reasonable balance between the amount of work to be done and the resources available. It can help save time and money. It can also be used to ensure a resource is not used beyond the given value during a project, even if this means increasing the project completion time. For example, if our resource histogram found that 8 workers required 1 week and 12 workers required a second week, then resource leveling would help us work out if we could use 10 workers on week 1 and 10 workers on week 2 to complete the project on time. Here's a resource histogram we drew in the previous video where each activity required only 1 worker. So the question is, if there are only 3 workers available, will the project finish on time? We can see that between days 11 and 16, there are actually 4 workers required. So what we need to do is we need to look at all the activities that are happening during these 5 days and decide which activity we can delay to enable the project to happen in the least amount of time. So activities C, D, F and G are happening between days 11 and 16. And we want to look at the float for these activities. So C has a float of 0 according to our cascade diagram. D has a float of 6, F has a float of 7 and G has a float of 15. So one of these activities needs to be delayed by 5 days in order for the project to be completed using only 3 workers. So obviously we can't delay activity C without the whole project being delayed, so we're going to try and avoid delaying the critical activity C. D can be delayed by 6 days, F can be delayed by 7 and G can be delayed by 15. Since D starts before day 11, we try to avoid delaying activity D. So if we delayed F by 5 days, it would still be completed by its latest finish time, and if we delayed G by 5 days, it would still be completed by its latest finish time. So moving either of these activities would enable the project to be completed by 3 workers and still finish on day 31. So if we look at this diagram, we can see that we have delayed activity G and the project can be completed with 3 workers within the given time of 31 days. So what if there are only 2 workers available? What will be the effect on the completion time? If we look at our resource histogram and level it off at 2, we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 worker days that need to be reallocated, and there are only 1, 2, 3 free spaces available. So we know that with 2 workers this project will definitely be delayed. So the project will be delayed by 13 days, ending on day 44 instead. Okay, so here's the other resource histogram we drew in the previous video, where we had more than 1 worker required for each activity. So the question here is, given that there are only 9 workers available, can the project still be completed on time? So we go to 9 on the y-axis and draw a horizontal line to help us visualize what needs to be done. So as we can see, there are 11 workers from between days 6 and 9. So it's these 3 days that we need to look at delaying activities. So again, we need to list our activities that happen on these 3 days. So that's C, D, E and F. And then we need to work out the float for each activity. So for C, we've got 11, take 7, take 2, which is 2. For D, we have 20, take 7, take 6, which is 7. For E, we have 15, take 9, take 6, which is 0. And for F, we have 11, take 3, take 6, which is 2. So we need to reduce these 3 days by 2 workers. So it'd be useful to know how many workers each activity requires. And we can do this by looking at the height of each of the activities represented on the histogram. So for C, C has a height of 2, so that's 2 workers. D has a height of 4, so that's 4 workers. E has a height of 2, so that's 2 workers. And F has a height of 3, so that's 3 workers. So E is a critical activity, so we're going to try not to delay E. C starts at the end of day 2 on day 3, so we're going to try to avoid delaying C as well. So we're allowed to delay D by 7 days in order for the project to complete on time, and F by 2 days in order for the project to complete on time. Now we need to reduce the number of workers by 2, so delaying both D and F would work. Obviously it depends on which one gives us the smallest delay. So if we look at both these activities in turn, we can see that if we delay activity D by 3 days, then it will still complete by its latest finish time, so it won't delay the project by any days. Whereas if we look at F, we can see it only has a float of 2, so if it's delayed by 3 days, it has a delay of 1. So the activity we want to delay is activity D, as this has no effect on the completion time of the project. So the project will still end in 20 days. So our next session will be on constructing a scheduling diagram.